Hello, I welcome you all to this class. Now today we are going to discuss one numerical problems which is related to the truss, and the truss is of simply supported type. And in previous class we have discussed about the fundamental of a frame, means how many types of frame, and the method by which how to get the forces in a truss member. So now we have a one example problem. That problem is on the screen. That determine the forces in the truss which is subjected to the horizontal and vertical load. Mention the nature of the forces in each case. So you have a one truss member is given, and in that truss the truss is subjected to horizontal as well as vertical loads. So also you have to find out the forces in each member, and then you need to tell that what is the nature of the forces, means either it is the tensile or compressive. So here you can see one truss member is shown, that is you can look at that this is A, B, right. So this is what you have a truss member, this one triangle, second and third, right. So each is having length is 4 meter, 4 meter and 4 meter. So here you can see at A you have a hinged support, but at B you have a roller support. So as you know that truss, two types of support can act on a truss, that is either it will be the roller support or it is the hinged support. So if the truss is subjected to the hinged support, it means that the horizontal as well as vertical reaction will act, but at the roller support only the vertical reaction is act. That we have discussed in the previous class, right. So now we can say that at A the horizontal reaction and the vertical reaction both will act. So let us show me that this is your horizontal this is the vertical reaction. Let's say this is A, so the vertical reaction name is the RA, right. As well as you have a horizontal that because of this hinged, there is a horizontal support will also act, which we call it as a HA, right. And how can we decide whether it is acting the left or right? Why? Because you can see there horizontal forces is acting, which is 8 kilonewton, right. So when you use the summation of H is equal to 0, it means that this value will get the minus, right. So you can say that is this will act towards the left hand side. So the horizontal forces, horizontal reaction at A will be HA, and it is act towards the left side. Why? Because of this load is acting towards right. Now at B you have a roller support, so only one reaction will act. That reaction we call it as a vertical reaction, is a RB, right. So this is what you have a RB. So again if you see there at E and G we have a two forces are acting. These are the vertical downward 3 kilonewton and 6 kilonewton. So I do means you do one thing, that draw this truss member. I'll show you like this. Okay, now then first of all what we need to do, we have to find out the horizontal as well as vertical reaction, and then at each joint we will use and find out the forces in the member by using the equilibrium condition, that summation V and summation H. So first of all we need to find out the horizontal reaction. So for horizontal reaction I can say that simply that you have a HA is equal to 8 kilonewton, and which direction it is acting, it will act towards the left. Why? Because this vertical horizontal force at E is acting towards right. So that's why the horizontal, this will be balanced only when it is acting in the opposite direction with same magnitude, right. Now we need to find out the reaction at A and B, that is vertical reaction at A and B. So RA and RB is equal to what? That you can say RA plus RB is equal to sum of these two forces, right. So simply you can say here that RA plus RB is equal to what? This 3 plus 6 is equal to 9 kilonewton. Let's say this is equation 1. Then we can take moment about A, or either you can take moment about B also. So I am taking the moment about A. So moment is what? Force into perpendicular distance. So these forces will be come into play, that is 3, 6 and the RB. Is it or not? and also you have a one horizontal force is given. So for that the vertical height is given, that is 1.5. So first of all we can write here that taking moment about A, right? So taking moment about A. So when we take the moment about A means what? I'll show you this RB. So RB is acting upward. So as this RB is acting upward, so the moment will be the anti-clockwise, right? So it is like this. So this is your pen, that is AB, and this my finger is the RB. So when the force is act, it will be goes towards anti-clockwise direction. So this at G, the 6 kilonewton load is acting downward. So when this load will act like this, right? So how means how it will be goes, that is clockwise, and because of this also the clockwise moment. Let's say this force 8 kilonewton is acting horizontal, and the vertical distance is what? That vertical distance is shown is 1.5. so let's imagine that 8 kilonewton is this, right? So this is what you have to find out the moment about this point. So force is this one, and this is the distance. So how it will be rotated? This is also clockwise, right? So all clockwise will be one side and anti-clockwise will be another side. It means that you can say the moment because of this 3 kilonewton, 6 kilonewton and 8 kilonewton will give you the clockwise rotation, and this RB will give you the anti-clockwise rotation, right? So now you can say RB into this total length is what? 4 plus 4 plus 4, that is 12, is equal to first load is 3 kilonewton, from this to A to F is the 4. So this is 3 into 4, right? Again the second one is 6, that is 4 plus 4 is 8. So plus you can say 6 into 8 plus that horizontal force 8 kilonewton. So this is distance is what? 1.5 meters. So this is also 8 into 1.5. So on calculation, wait. So when you do the calculation, you will get the RB value, that RB is equal to 4 is 12, it's 48 plus this is also 12. So 12, 40. RB is equal to 6 kilo Newton, right? And where it is acting vertically upward. So we need to show that arrow, right? Now we need to find out the RA. Simply you can substitute this RB into this equation, you will get the RA. So RA is equal to what? That RA is equal to 3 kilo Newton. Okay, now then we can see these members are inclined. That means what? That A is inclined, this is also inclined, this is also, means these all members are inclined. So the inclination we need to find out, right? So for finding the inclination, or you can say that the dimension of the each triangle is equal. Why? Because this is 4 and the height base is 4 and height is 1.5. For this also base is 4 and height is 1.5. For this also base is 4 and height is the 1.5. Means if one of the triangle will take and will find the inclination, that inclination will be valid for each triangle. Is it or not? Now, so for that, what I am doing, that I will take this triangle which is the ACF. Okay, so here you can go, just wait. So in triangle ACF, that triangle we have taken. So ACF is how? So let's say this is the 4 meter, it's given, and the height of the triangle is 1.5 meter. That is also given in the question. So if I draw one, means if I bisect this triangle about this point P, right? So this is your A, C and F, right? So as I bisect this AF about from A at the point P, so this AP is equal to PF, which is 2 meter. So this is your 2 and this height is 1.5. Now you have this, if you need to find out this angle theta, right? So this triangle theta, this angle theta is what? Let's say that again you got one triangle, this angle is the theta we have considered. This is the right. So this is what 2, and this will be the 1.5 because it is the height of the triangle which is given in the question, right? So this is your opposite and this is the adjacent. So now you can say, or directly you can find the cos theta and sin theta also, right? So this is your hypotenuse. So hypotenuse is what? Let's say this is P, C and A. So AC is equal to, so in the triangle, right, so the triangle is here. This is your A, P and C. This hypotenuse you need to find. This is 2 and this is the 1.5 meter. So AC is equal to what? AC is equal to root over of the PCA square minus PCA square plus APA square, that is 2A square plus 1.5 whole square. So we got this, that is 2.5. Let me check. Yes, so this is the 2.5 meter, right? Now if I say cos theta, so cos, this is theta you have to find. That cos theta is what? Opposite by adjacent by hypotenuse, means in this triangle cos theta is equal to adjacent by hypotenuse means 2 by 2.5, right, which is nothing but the 0.5. Direct value we got. Similarly sin theta, so sin theta is what? Opposite by hypotenuse, which is 1.5 by 2.5, right? So that value is 0.6, right? So why? Because while we members are inclined, right? So as the members are inclined, so when you find out the component, that component you'll find in terms of the cos theta and sin theta, right? So that's why wherever the cos is required, we will take directly 0.5, and wherever the sin theta is required, we will take the 0.6. Now the everything is over, that we calculated the reaction, vertical and horizontal reaction at each members at each end, and we also calculated the angle with which the members are inclined. Now we need to take the joint and then find out the forces in each member. One by one we'll choose the joint. So first of all we'll take the, means always remember that you'll choose the, means start the calculation from the end of the joint, right? So that will be better, and specifically that where you'll get one of the forces. So if you see in a member that we already calculated, means we already know the reaction at this point, the horizontal reaction, and at this point, and these 2 points, these two joint, that is A and B, are the which we call it as a end joint. So first of all I'll take this joint A, right? So joint A is how it is located, that is vertical reaction is acting, and then this member and this member, right? Now so this is acting vertically up, so in this member the compressive force will act, and in this member the tensile force will act. That you have to balance. So first I am taking the joint A. So now you can, yes. So now you can say here that joint A, right? So how the joint A is look like? So let's say this is the joint A, this is the vertical reaction, that is horizontal reaction, this is towards left, and this is the horizontal member which tensile force will act, and this is the inclined member, this is the C, right? So this inclination we have considered it as a theta value will be something else, right? So this is your RA is acting vertically up. So as this is acting vertically up, so in this member, that is in this is your A, this is the F, right? So in this the FCA force will act, which is the compressive, right? And in this the forces is the FA, F is the force and F is this one and A is this, right? So now what we need to do, we have to simplify the problem by applying the equilibrium condition. Means what? Summation of V is equal to 0 and summation of H is equal to 0. Alright. So first of all, I'll use the vertical forces. That here summation of V is equal to 0. So what are the vertical forces? This vertical reaction which is acting upward, it will be positive, and this inclined force whose vertical component we need to take. So vertical component for this FCA is what? FCA sine theta, right? So it will be balanced. So you can say RA is equal to FCA sine theta, and sine theta value you already got, that is 0.6. So now you need to find out the FCA. So FCA is equal to what? That FCA is equal to RA, and RA value we know, which is the 3 that we have calculated, 3 by 0.6. So some value will come, it is 5 kilonewton, right? And how it is nature? The nature of this force is compressive, that C for the compressive. So one of the forces means one force we got in a member AC, right? Now we have to find out the forces in the AF. So for that, again you can write summation of H is equal to 0. So what are the horizontal forces? See, this is the horizontal reaction HA, which is acting left direction. FFA, it is horizontal towards right, and its component, that is FCA, horizontal component. So arrow is down, means it is compressive. So horizontal force will goes towards the left. So it means these two are having same direction and this is having another direction. So directly you can write, that is FFA is equal to what? HA plus FCA cos theta, right? That FCA horizontal component. So HA is what? 8 kilonewton, that is we calculated, and FCA is this value now you can take, that is 5, and cos theta is 0.5, right? So into 0.5. So what is the value? Sorry. So this is the 8 plus this is 5. Sorry, this is the 0.8 will come. Right. 2 divided by 2.5. Yes, 0.8, that is a 0.8. Right. So this force will be, this is the 0.8. So it is the 12 kilonewton. And how it is? That is tensile. So you can write it here T. Okay, so now we got the forces at the joint A, means in member AF and AC. Now we'll choose another joint, that then we'll find out the rest of the forces. So let's say here we are choosing the joint C. Why? Because these forces we already got. So if you choose this joint C, so this joint C is connected by AC, AF and CD, right? So if you look at this, so in this you have a compressive force is applied, right? So this time in this also the compressive force, in CD the compressive force will act, but in FCF that is the tensile force will act, right? So now just wait, we have to adjust actually. So now we can say, yes, it is shaking actually, the joint C, right? Joint C. So how the joint C is connected? This is the C and this is your AC, CD and CF. Is it or not? Now, so there is this inclination is theta. Why? Because this is theta, so this is also theta, and this will also theta, right? Now this is C, this is your F, A and D. So in this the force is what? That force is the FCD. In this the force is FCF, right? And in this the force is FCA. Okay, now FCA we already calculated in the previous joint. So here if you look at that, in this the FCA is a compressive. So here also it will be compressive, right? And as this is the compressive, so this will also compressive, and this will be the tensile, right? So now you can say summation V and summation H. Sorry. right? So you can say here that summation V is equal to 0. So what are the V? That this its vertical component and its vertical component. So vertical component for this is what? FCA sine theta. It will goes up, and it is, the arrow is down, so it will goes down. So you can say FCA sine theta is equal to FCF sine theta, right? Means what? The sine theta get cancelled. FCA is equal to FCF. FCA is equal to FCF. And what is that value? That FCA we already calculated, 5 kilonewton. So you can say FCF, right? FCF is equal to 5 kilonewton, right? And what is the FCF? That is tensile. So you can write T, right? Now we need to find out the H, that is, we'll apply the summation of H is equal to 0, then we'll get the forces in the CD member, right? So here only you can say that summation H is equal to 0. I'll show you. So this is what? Horizontal component. This is horizontal force itself, and its horizontal component and its horizontal component. If you look at, this is arrow like this, so its horizontal component will goes right. It is arrow like this, so its also horizontal component will goes right. It means that these two forces are added and this will be balanced, that is, this will goes left side, right? So now you can say FCD is equal to FCA, horizontal component is cos theta, plus FCF also cos theta, right? So FCA is equal to what? 5, and cos theta is 0.8. This is 0.8, sorry. So this is 5 into 0.8 plus 5 into 0.8. 5 is the 40, that is 4 plus 4 is 8 kilonewton. So FCD is 8 kilonewton. And what is the nature for this force? The nature of this force is compressive, right? Why? Because the member is like this. Is it or not? Now it means that the point joint C also we get the forces in the member. Now we'll choose another joint. So another joint is what? That in this manner you can move. So joint C is A is over, C is over. Now you can come to the F. Why? Because if you choose this D, there is a little bit of complex than this point. Why? Because here the load is given, and this load in this member we already calculated the load, and in this member also we calculated the load, right? So but if you look at the structure of the joint F, it is what? The vertical force is acting, 3 kilonewton is downward, and in this member CF, this FD, and 1 like this. So how it is? This member, this member, this member, this member, and this vertical forces, right? So if you see this FCF is how the FCF is the tensile, so this will also tensile, this will be compressive, these are tensile, and this is tensile, right? Now so it's very simple, you can easily do this, right? So now it's, you leave it like this also. We'll do another page. Yes. So now you can see here, very carefully you can see that we can write down the joint F, joint F, right? So this is your F, joint F. So this is your AF, this is the FG, right? You can refer your question, right? Why? Because every time I can't turn the pages. So this is your CF, this is your DF, right? And this is the vertical load which is acting downward, 3 kilonewton, right? So this is the tensile. Why? Because in previous one it was tensile, it is compressive, it is tensile, and it is tensile away from the point. So this point, this name is F, right? So in this force is what? This is the F, FA, FCF, right? This is the FDF, and this is the FFG. Okay, now so this angle, that is, this angle is theta and this angle is theta. So theta and theta we got. right? So if you use the summation of V is equal to 0, means what, this vertical force is downward and this is arrow up, so it will goes up, and this is vertical down, arrow is down, so vertical, means this FDF and 3 will be added and this will be the balanced. So now you can say summation of V is equal to 0. So what is that? That FCF sin theta vertical component is equal to FDF sin theta plus 3, right? So we need to find out DF. So DF is equal to what, you can say that FDF sin theta is equal to FCF sin theta minus 3, right? So FDF is equal to what? FDF is equal to FCF sin theta minus 3 by sin theta, right? So FCF is how much? FCF we already calculated, which is the 5. Sin theta, theta is 0. I will check. Yes, so theta is equal to, you got sin theta is 0.6 right now. So when you substitute, you will get the FDF. So here put the values. FCF is 5 into 0.6, right? Is it? Wait. This is what? This is vertically up. This is vertically down. Right. So this is what you have. A FCF is 5 into 0.6 minus 3 by 0.6. So this will be 3 minus 3 is 0, right? So it means that there is no forces in FDF, that FDF is equal to 0, right? We got. Next we have to resolve the horizontally, right? So you can say next, that is summation of H is equal to 0. So summation of H is equal to 0 means what? This is horizontal, this is horizontal, its horizontal component and its horizontal component. But if you look at, this is going left, its arrow is like this, so its horizontal component will also left. Its arrow is also downward, so this is also going left, and this is balanced. So it means that FDF horizontal component, FCF horizontal component and FFA should be equal to FG, right? So directly you can write that balancing, you know, I think, right? That is FFG is equal to FFA, okay, plus F cos theta plus FDF cos theta, right? Why? Because these all are going towards one side, so it's, what is that? Then FFF is equal to 12. It is 12 plus FCF is equal to how much? That FCF is equal to 5 into 0.8 plus FDF is equal to 0. It won't affect, so 0 into, if you want you can write 0.8, right? So it is what, 5 8s are 40 and 12 plus 6, this is 60 kilo Newton, right? So this is the FFG we got, 16 kilonewton. And how it is magnitude? That is tensile, so you can write T. Okay, it means we calculated the forces in the member which is connected at joint F, right? Next joint we can take as a D. So I'll show you that this D will take. Why? Because this force we already calculated, this is calculated, this, and this is remaining, that DG and DE we have to calculate, right? So now here only you can say joint D, right? So how it is connected? Let's say this is your joint D, this is D to C, D2E, right, and this is the D2F, and this is the D2G, right. So these two forces, if you look at that in the previous one, in this member it is the compressive, so this will also compressive, this is also compressive, right, and this is the tensile, that is FFD, we got the tensile right now, and this is the compressive. So here you have this, the joint D, this is your C, E, right, this is the F, yes, and this is the G. So now you can mention the force, that is FCD, FD E, right, and this is the FDF, as per the previous name we are naming right now. So this is what you have, a FDG, you can say. This inclination is theta, and this is also inclined by an angle of theta. So again you can say summation V and summation H is equal to 0. So what is that vertical? So its vertical component, that is FDF vertical component and FDG vertical component. So you can say this arrow is away from that D and this is towards the D. It means that it goes vertically up and this will goes vertically down. So simply you can say that summation of V is equal to 0, and what it's that FDF vertical component is sine theta is equal to FDG sine theta, right. Why? Because these are balanced, one is going away from that D and one is towards the D. So sine theta get cancelled, FDF is equal to FDG, and FDF we already got in previous joint, that is D, right, 0. It means that in member DF we don't have any forces right now. So now you can say sine theta and sine theta get cancelled. So here FDF is equal to FDG, and that means FDG is equal to what? 0. No forces in the member of DG like a DF, right. Similarly we can write on the summation of H. So summation of H means what? This horizontal force FCD, horizontal force DE, its horizontal component and its horizontal component. So if you look at this arrow is downward, it means that its horizontal component will goes towards the left. It is like this, right. So as the arrow is like this, so horizontal component will goes towards the left. So it means that these two forces, its horizontal component of these two forces will be towards left, and this force is also left and this is right. It means this FCD is equal to sum of FDE plus FDE horizontal component and FDG horizontal component, right. So now you can say summation of H is equal to 0. What is that summation H is equal to 0? This is like this whole left, right. So now you can say here, let me check please, FCD, right, FCD is equal to this is what FCD is equal to FDE, right. Now we can say FDE plus FDF horizontal component is cos theta, okay, plus FDG cos theta, okay. So FCD we have calculated, right. FCD we have calculated, yes, we must calculate FCD. FDE is equal to is given FDF and FDG, so we can substitute the value and get the horizontal forces, right. So wait, that will check this value. FCD is equal to 8, so this is what you have, you can write 8 kilonewton, and FDE is equal to this is what FFG is 16 and FDG is 16. FFG is 16. So FFG is not there, right? Wait. So FCD is equal to 8 and FDE is equal to FDE we have to calculate. So FDE as it is, and FDF is equal to 0 plus 0, right? And again plus FDG. That FDG is okay, that's where I get confused, right? So this FDE is equal to 8 kilo Newton. Okay, so you can check. So now we get the FDE, that is 8 kilonewton, and how it is, if you see, this is the compressive. So you can write that is the C, compressive, right? So E is over. Now we'll take that D joint is over. Now we can see the next joint is the G, right? Why? Because this load, this and this, and these are the members. So again, if I say here it is the downward, right? So in this we already got the compressive, so it will be tensile, and these two are already tensile, right? So now you have a next joint is joint G. So joint G. So joint G is what? This is the load, which is 6 kilonewton. This is the horizontal member. This is horizontal member. This is inclined, and this is also inclined. So in this, the arrow is like this, arrow is like this. This force is what? 6 kilo Newton, right? So this is your D, this is your G, right? So this is the E, and this is the B, finally last, and this is the F, right? So in this member, force is what? That is FDG. This is the FGE, right? This is the FGB, and this is the FGF, right? Now, so how it is? It is the compressive, this is the tensile, these are tensile. So now again, these are inclined by an angle of theta and theta. So again, you need to find out the vertical and horizontal component. So vertical component is what? That you can see the vertical force is 6 kilonewton, and these two are balanced by the means these two forces, means this arrow is downward, so its vertical component will be down. So this force and this force will be added, and it will be balanced by the vertical component of FGE. Okay, so simply you can write down the equation and get the forces in the member. So here I can say summation of V is equal to 0. So what is that summation of V? That this 6 plus its vertical component is FDG sine theta is equal to FGE sine theta. Is it or not? Now, so we need to find out the FGE only. So FGE is equal to what? That FGE is equal to 6 plus FDG sine theta by sine theta. Okay, so you have a 6 plus FDG we already calculated. What is 0? So it's nothing will be happen. So it is what? 0.6. So it will be 10 kilonewton will come. That is FGE is equal to 10 kilonewton. And how it is? FGE is the tensile. So this is the T, right? Now then we can find out the horizontal component. Wait. So now we can say, so then we can write down the horizontal component, that is summation of H is equal to 0. So what is the summation of H? I'll show you again, that G only. So at G, this horizontal component is, this is towards left, this is right, this will be right, and this is also right. Means these three forces, FDG, FGE and FGB will be added, and this is balanced by the FGF. Okay, so now you can write, that is resolving the forces horizontally. Wait, yes. So resolving the forces horizontally means it's blur, wait. Right, so resolving the forces horizontally in the sense that F GF is equal to, it is going left, and the rest of the forces are going towards the right. Right, so this is the FDG, horizontal component is cos theta, plus FGE cos theta, plus that horizontal force itself, that is the FGB. Okay, FGB we have to calculate actually. Right, so these two will be come to this side, but before that I'll tell you that FDG is equal to what? That FDG is 0, so this will become 0. Right, so only we need to bring it this side. So FGB is equal to FGF minus FGE cos theta. Why? Because it is 0. Right, so now FGB is equal to, FGF is how much? That FGF is equal to 10. We just now we calculated FGE, right? So it is 16 minus 10 cos cos 8 means that is cos theta, that is 16 minus 10 into cos theta is 0.8. So this is, so now it is how much? That will be 8, right, kilo Newton. So this is your FGB. So the forces in GB we calculated, and this is what? This is the tensile. So you can write T. Right, now last joint we will use, that is the E. Right, so last joint is E. So this horizontal force in this like this, that is compressive, and this is the tensile, and this will be the compressive. Right, so last member you can say, that is joint E. Okay, so E is here, and 8 kilonewton of force is given in the question, right? And this is like this, D, this inclined member, and this is the inclined member, right? So here you have a D, and here you have a G, right? And this is the B, right? So at the load is acting vertically up, vertical reaction, so it will be compressive. This is the tensile, this will be the compressive. Why? Because it is like this, right? So now, and this angle is theta, and this angle is also theta. So simply you can say summation of V is equal to 0. What are the vertical component for this? That is, let's say this is E, right? So its vertical component is what? FEG sine theta, right? That balanced by the FEB sine theta. Why? Because EB is compressive, and GE is the tensile. So just wait. So you can say here that FGE sine theta is equal to FEB sine theta, right? So this sine theta and sine theta will get cancelled. It means these two forces are equal, right? And FBE is equal to what? That FBE is nothing but the 10 kilonewton, right? We already calculated. So this FBE is equal to 10 kilonewton, or FEB is equal to 10 kilonewton, and FEB is how? That is the compressive. So this is the C. That GE we already calculated, right? So G is here, we calculated in the previous joint, that is 10 kilonewton right now. So now we calculated the forces in each member of a given truss, right? So now what we need to do, we need to show the values on that given truss. So for that, again I'll draw the figure here, that, just wait. So this is how your truss member is given, right? Okay, so these are the truss member is given. So now you have a, here you have a reaction, and this is the horizontal reaction. Wait. So in this A, or I'll show you here only, this will become wrong right now, actually not wrong. So this is what the, in this member we got the 5 kilonewton force, right? So these are the compressive, so it is like this, and this will be like this, the magnitude is 5, and in this we have a 12 kilonewton force, right? So this is the 12. In this also we got the 5, so this is 5, right? In this member we got that 8 right now, so this is the 8 kilonewton, and in this member we got the forces that is also 8, right? And in this we got, this is 10, and in this we got 16, right? In this we got 8, and here we got the 10, right? But we don't have any forces in DF and DG, that we got 0, so we need not to show right now. So this is how you can represent after calculation, right? That you need to draw the, again the truss diagram, and then show the arrow and magnitude. So this is the way by which you can get the forces in the member of a given truss by using the method of joint. In next class we will solve the problem which is related to the cantilever truss. Thank you.